Hello guys and welcome back to our programming unit for the iGCSE Computer Science syllabus. Today we are looking at arithmetic, logical and Boolean operators, which many of these topics have been covered up until now. We've looked at certain concepts within the Unit 7 pseudocode unit, and we've also covered these concepts in the programming unit so far in our Python examples and just basic methods that we use when we program, which I'm sure you'll recognize in this lesson. But we have to make sure that we go through everything and there's nothing that we have missed ready for the paper 2 exam. And as you can see, the first learning objective for today, totaling and counting. This has been covered across both Unit 7 and Unit 8 so far, but we will cover them very briefly in this lesson, as well as the use of arithmetic, logical and Boolean operators, which include all of these operations here, and we'll go through each one. Again, looking at some examples within Python, but more importantly, understanding the use of them and how they work. So first of all, totaling and counting, like I've mentioned, has been covered many times in the course so far. And as just a reminder, the purpose of totaling is to produce a sum of numbers that may exist in your program. So in our example here, we've got two variables called total cost, which contains 50, and cost, which equals 10. Adding them together and storing them in the total cost variable would simply print out the number 60. So the most important thing to take away from this is that we need to save the answer back into the original variable. Otherwise, if we just did total cost plus cost, 60 will be produced, but it wouldn't be saved anywhere as our program carries on. So the most important part, guys, when it's totaling is that we save the answer in a variable, whether it's the existing variable or whether it's a new one, that's up to you. But totaling, you need to save the answer. And just as a reminder, in Python, you can shorten this part of the code here, and you can just put total cost plus equals cost. In pseudocode, you have to write the full thing, but in Python, you can use plus equals. Counting was very similar. However, we are simply incrementing it by 1 or counting something within the program and keeping a track of it that way. But as you can see, the process is very similar. We've got a variable called number of items, which contains the number 5. And if that number is to go up and I need to count more items, I add 1 and again save the answer in the original variable. Same applies with the plus equals. You just put plus equals 1 and this would increment it by 1 and save the answer inside the variable. So I'm not going to run them in Python. I'm pretty sure you can understand what's going on there. But by all means, if you want to give it a go yourself just to see what happens, go ahead and do so. Now, when it comes to arithmetic operators, all we have to think about with arithmetic is basically maths. As you can see, add, subtract and divide here. These symbols we've covered already, and in Python they are exactly the same. So this is essentially the pseudocode variant, and this is how it would look like in Python. So the only one you might not be familiar with is possibly the divide, which is a /, and then the remaining 3 might be completely new, and we have a upwards arrow for to the power of. So if we had 4 to the power of 2, for example, that would be 4 squared, and that would be 16. Or in Python, if we had 4, 2 asterisks, and then a 2, that again would produce 16, and it's simply to the power of. So rather than writing 4 squared like this, we use the up arrow in pseudocode or the double asterisks in Python. And then finally, we have mod and div, which I don't think we've covered yet, and is why we're doing it now. And if we start with mod is short for modular division, or basically what we call remainder division. So if we go back to when we were very small, and we think about the remainders when we divide, and we'll just do a couple of examples here. So if I was to say 16 mod 5, basically there are 3 5s in 16 because it goes 5, 10, 15. And if we go back to when we were small, we can figure out that the remainder is 1. So 16 mod 5 would actually return 1 as the result. We just do a couple more. So if we did 10 mod 3, we should know that 10 divided by 3 is 3. Remainder 1. So where I see students get mixed up all the time is that they do 10 divided by 3, which naturally they think 3.3, and then they sometimes think 0.3 is the modulus. However, you need to revert back to very basic division and realize that 3, 6, 9, so it's 3, remainder 1. So again, the answer would be 1. If I just do one more to clarify, and if I do 20 mod 9, so you do 20 divided by 9, and there you should realize 2 9s makes 18. So 2 9s equals 18. And then there are 2 left over. So 20 mod 9 would actually return 2. So it's the remainder. Where modulus can serve a function is that any number mod 2 that gives a result of 0 would prove that a number is an even number. So for example, 10 mod 2 equals 0. 10 is divisible by 2 with nothing left over. 8 mod 2 also equals 0, as 2 goes into 8. Basically, any even number that you mod with 2 that gives the answer 0 would prove that it's an even number. So this can come in handy if your program needs to check for even numbers, which I have seen in past paper questions. So just bear that in mind, and hopefully I can use an example showing you how to use it. Div, if we just go to the other side, div is basically floor division, or division where we round down, and div simply returns the whole number, not taking in the decimal, or in our case the remainder. And I do 10 div 3. This would return 3 and only 3. So although the answer again is 3.3 or 3 remainder 1, the 0.3 we get rid of and the remainder 1 we would also get rid of. So the answer is just the whole number, or essentially rounding down if there's a decimal point afterwards. So again, 9 div 4, so 9 divided by 4 equals 2 point something, but again we don't care, it's 2, simply 2. Okay, 4 goes into 9 twice. I'll do one more just for clarification. If I do 20 div 6, 20 divided by 6 is 3 point something, and again we just keep the 3. 6 3s makes 18, and that's all we need to worry about. So floor division, or integer division sometimes call it. And basically in pseudocode you would write mod and div, but in Python modulus is represented by a percentage sign and div is represented by a double forward slash. So all of these would be 10 double forward slash 3, 9 double forward slash 4, and 20 double forward slash 6. Over to this side, we would have 10 percentage sign 3, 16 percentage sign 5, and that's how we'd represent mod and div in Python. And then moving on to logical operators, we've got our greater than and less than signs, which you should be familiar with. If not, I've mentioned in the previous video, if you ever get mixed up, there is the hungry crocodile method, which you might find easier. Or the way I remember is that less than begins with an L, and if you make an L with your fingers, you can kind of recognize that it's the less than sign, and that's your left hand. So it's all about the L's for me, but again, whichever method works best for you. But basically, all these operators are the same in pseudocode and Python, except for equals and not equals. So something we have to remember in Python, that if we are checking for a equal value, we need to use the double equal signs, and we can also check if something is not equal to something by using the exclamation mark. So basically, if we're checking for a name, and if I said if name equals Joel, print you are Joel. Or what you could do, if name is not equal to Joel, print you are not Joel. So that's an example of when you could use the not equal sign. But again, this is how we do it in Python, and in pseudocode it's just one equal sign, and the not equals is the less than and greater sign together. Remember, one equal sign in Python. So if I had a variable name equals Joel, in pseudocode this will be represented as name arrow Joel. So that's where students also get mixed up, and is something that's worth mentioning. And finally, we have our Boolean operators, and we've got and, or, and not. This is the pseudocode in capital letters, and Python's exactly the same except in lowercase. And Boolean operators can be used to check for multiple conditions, for example, checking if a variable meets multiple conditions. But what we will do is go through some examples using these and get them a little run in Python. So to do so, let's write a simple program that compares two numbers and outputs a message for the following scenarios. We will need the logical operators that we've previously discussed, and we need to check if both numbers are equal, if they are not equal, and then which number is bigger. So this is just for logical operators just now while we get the hang of it. And if we take two numbers as an input, this time I'm going to take them in as a float. Up until now, you've seen me write int quite a lot for integers, whole numbers, but I'm going to write float just so we can see it and know that this is a floating point number. Step 2, to simply check if they are equal, we would use two equal signs, and we can say if number 1 equals number 2, then print both numbers are equal. What you need to get into habit of is if you see the two equal signs here, this is the exact same thing as saying is the same as or is equal to. It doesn't mean store, so is the same as or is equal to. And you need to realize that one equal sign is simply to store a value into a variable. So in the top example, you can see we've used one equal sign, and this stores the input inside the variable, and that's very important. So this checks if they are equal to each other. To check if they aren't equal to each other, it's simply an exclamation mark and an equal sign, and this would print out that the numbers aren't equal. And finally, to check which number is bigger, we simply use the more than sign. And it doesn't matter which way around you do this, but in my case, I've asked if number 1 is bigger than number 2. And if it is, I will print out number 1 is the largest. Otherwise, I've got an else statement. number 2 must be the largest if this condition wasn't true. Likewise, in the previous example, I could have said if number 1 is not equal to number 2, print they aren't equal. I could have said else, print they are equal. Because if they aren't equal, this is ran. Otherwise, they must be equal. So I can say they are equal in this case. But either way, that's just an example of how you would use the two equals signs and the not equals to in a scenario. Next, if we look at Boolean operators and where we could use those, we are going to make a program that checks if two numbers are both positive. We're going to check if just one is positive or neither are positive. In each case, the program should output a suitable message. And again, we will need the Boolean operators in order to do this. So first and foremost, if number 1 is more than 0 and number 2 is more than 0, then the program would print out both numbers are positive. Notice how it's and in the middle, because number 1 and number 2 both have to be positive in order for this condition to run. If we change and to or, then what we would do is check if either number was more than 0, and we could print out at least one number is positive. So in the and statement, they both have to be more than 0, but in the or statement, only one has to be. And then what we can do to use a not statement is we can say, if not, number 1 is equal to 0 or number 2 is equal to 0, the not basically means the opposite. So basically, if number 1 or number 2 are 0, this would return true, but we're checking for the opposite, which means it will be false. So basically, it checks for both numbers, and if either or is 0, and if they aren't, it will print neither of them are 0. What I will do, I'll give this one a run so you can see it in Python, and we'll take number 1 as an input. So number 1 equals, I'm just going to use an integer in this case, number 1 equals int input. Then I'm going to just copy and paste it, change this to number 2. Then I said, if not, number 1 is equal to 0, or number 2 is equal to 0, print neither number is 0. Else, at least one number is 0. And if we just type in number 1 as number 1, and number 2 is number 2, neither number is 0. Let's run this again. Let me do 1 as 1, and then 2 is 0. At least one number is 0. And it prints out at least one number is 0. So this one is a little bit confusing, but by all means give it a go and try and get your head around it. But basically, if not is checking for the opposite and checking if it's not true. Okay, so if this statement isn't true, then this statement will run. And then while we're here, guys, I just want to quickly show you the modulus in action. And what I'm going to say is number 1 equals an input. And I'm going to check if this number is an even number or not. So what we're going to do is we're going to check if number 1 percentage sign 2 is equal to 0, print number is even. Otherwise, number must be odd, so print number is odd. So print number is odd. Let's give that a run. Let's enter number 3. Number is odd. Let's run it again, and this time type in an even number. So 4, number is even. There's the mod working in action. And like I said, any number mod 2 equaling 0 proves that the number is an even number. So that's it for this lesson, guys. I'm just going to come back to the learning objectives, where I hope you can now read through these and explain the meaning of each one. The hard part now is knowing when to use these and applying this knowledge to a program given a certain scenario. But as always, guys, this is the skill we're trying to learn. And by learning these foundational skills, hopefully that's giving us the knowledge in order to progress with our programming. And if not, just knowing what all of these terms mean is required by the course. And there are plenty of questions in exams where you might be required to explain what they mean or to highlight arithmetic, logical, and Boolean operators in code. And by simply identifying them, you could still pick up marks. So I hope you've managed to follow along. The next lesson, we're going to step it up a bit, and we're going to be looking at nested statements with the use of if statements and while loops. But as always, guys, I hope to see you there.